This video is to explain about the quicksort algorithm and its complexity. Quicksort is a divide and conquer sorting algorithm that works by selecting a pivot element, partitioning the array around the pivot, and recursively sorting the subarrays. For example, consider the given array. In the above array, two pointers are pointed at low and highest index. Select a pivot which is commonly the last, first, or any random element of the array. The pointer I searches for an element greater than pivot and j searches for the element lesser than the pivot. Increment I until you find element greater than pivot and do the same with j. Swap the numbers at I and j. When I is greater than j, swap j with pivot. Consider the given array. The last element would be the pivot. Search for the elements greater than pivot on left side. For example, here 7 is greater than 6. Search for elements lesser than pivot on right side. For example, here 4 is less than 6. Swap the two numbers. Continue the process uh, and we find 8 on the left hand side and 5 on the right hand side. Swap the two elements. The process is continued till both the pointers are next to each other. Now the elements lesser than the pivot are on the left hand side of the array and the elements greater than the pivot are on right side of the array. Then swap the right side element with the pivot. For example, here 8 is swapped with 6. Now repeat the process with left subarray where pivot would be 2. Continue the process till left subarray is sorted. We again increment the pointers and swap the elements based on the conditions given. Now again the array is sorted and divided into left and right subarray. As the left element consists of only one, it is already considered sorted. Now the left subarray will be having pivot as 4. Now sort the elements. Now the left subarray is completely sorted and we move on to the right subarray where the pivot would be 8. Now continue the process till right subarray is also sorted. Now swap the elements 8 and 9. Now the array is completely sorted. The pseudocode is given as the following. Coming to the best case scenario of the quicksort. The best case scenario of a quicksort occurs when the pivot always splits the array into two equal halves. That is, the recursion forms a balanced binary tree where each level divides array into smaller parts, that is a half of each array. Each level of recursion takes C and time, where C is a constant. The depth of the binary tree is given as n by 2 power k, where we can give the number of levels in the recursion tree as log n base 2. Since the array size is reduced by half at each step. Since each level takes big O of n time and there are O of log n levels, the total time complexity is given as big O of n log n. And the worst case scenario of quicksort is given as when the pivot always picks the smallest or largest elements, leading to highly unbalanced partitions. The worst case scenario generally happens in a sorted array of a quicksort. Instead of dividing the array into equal halves, each recursive call reduces the problem size by only one element. This results in a linear recursion depth of n levels. Mathematically, the sum of the operation follows as n plus n minus 1 plus n minus 2 and so on plus 2 plus 1, which gives big O of n square complexity. According to the Master's theorem, the recursive algorithm can be given as T of n equal to 2t n by 2 plus n. By comparing it with the Master's relation, we can get a equal to 2, b equal to 2 and k equal to 1 and p equal to 0. While comparing log a base b to k, we can conclude that it comes under second case of Master's theorem. So the complexity of the quicksort would be theta of n log n. Thank you.